In lesson 7-2, we're going to begin talking about sets and set theory. So there are some definitions that you need to understand before we get started. If you look in the box, the first one you will see is A union B. This sign that sort of looks like a capital U means you want everything that's in set A plus everything that's in set B. Put them together, okay? And that's exactly what this definition says. You want all the values of x. This vertical line right here means such that x is an element of A or x is an element of B. So in other words, I'm going to take everything that's in A and everything that's in B, and that becomes my new set when I put together these two sets with this union sign. Now, if you look at the one below it, it's an upside down U. That is the intersection set. In other words, I'm using all of the values of x such that x is an element, and if you'll notice, this is the symbol we use right here for element, of set A, and x is an element of set B. So I can only have values that are in both of the sets when it's an intersection sign. So they have to overlap in order to have any members in this set. If they're completely separate and none of the elements are the same, then my intersection set would be the empty set. This sign right here that looks like an apostrophe after the set A is called the complement. Oftentimes we will just call it A prime, and it simply means we want everything that is not in set A. If you look at this notation right here, it means we want all the x's that are an element of the entire or the universal set such that we want the x values that are not part of A or not an element of A. So you need to make sure you understand these symbols and recognize them. I have a few more listed here. This one that looks like sort of an elongated C means subset. If something is a subset of another set, it means that everything in that set is included inside a bigger set. For example, if I had a circle that was set A, and inside this circle I have another set that's B, this would mean that B is a subset of A, because everything that's in B is included in A. We've already talked about the symbol that looks sort of like a rounded E, means element of. In other words, we're going to identify that something is a member of a set if we use this symbol. And then the last thing in our definition is disjoint sets. If you have an instruction that asks you to find disjoint sets or makes a comment about sets being disjoint sets, it simply means that if you were to take the intersection of those two sets, it's the empty set. They don't overlap at all. That's what disjoint would mean. Now, let's go through and practice how to identify the correct answer for these questions. We're going to list the elements that would be in the set that they're describing. So if you look at number 1, we have some numbers in the first set, and then notice this is the sign for intersection with another set. So if it's an intersection, I list only the elements that are in common between both of these sets. And if I go through and I check, I see 3 in both of these sets, so that's going to be an element, comma. 6 also happens to be an element in both sets. Now 7 is an element in the first but not in the second. 8 is an element in the first but not in the second. I do see that 11 is in both of these sets, and that's going to be the last one that occurs in both. Now if you look at number 2, what's different this is not asking for the intersection, but it's asking for the union of these two sets. That means I've got to list every element from both of these sets. So I'm going to have 3, 4, 5, 6. Notice 6 is in both of them, but I only write it down one time. You're not going to repeat for numbers that are included in both. 8, 9, 12, and 14. Now the order you write them in really doesn't matter. I did put them in ascending order from least to greatest, but if you wanted to write everything that's in the first set, and then just go back and take the things in the second set that weren't included in the first, that would be okay too. Look at number 3. You have to write the set that would be the union of these two. I want you to take a second, look at it, and think about it. See if you can identify for me how many different letters will there be in the union set. And if you go through and list them, there should be 8 different letters. You would have A, B, C, D, E from the first set, and the new letters in the second set that haven't already been written down are I, O, and U. Now, number 4 is a different question. This says, is B an element of U? And then they tell us that U is the set with A, B, and C inside. So is B an element of U? The answer to that question is yes. Now there's a second part to this question. Is F an element of U? And if I look at U, it only has A, B, and C in it. F is not in there. So the answer to the second part of the question is no. Now if you look at number 5, we are asked to give the intersection of this first set, the numbers 1 through 9, intersected with prime numbers that are less than 10. Now let's have a quick discussion about what makes a number prime. If a number is prime, the definition is it's divisible only by itself and 1. Now, be careful. A lot of students will make the mistake of saying that the first prime number is the number 1. Technically, that doesn't meet the definition because itself and 1 would be the same number. So the smallest prime number is going to be 2, and it will be the only number that's even that is prime. So 2 is the smallest prime number. The next prime number is 3. It's divisible only by itself and 1. I'm going to skip all the even numbers from now on because 2 is the only one that's prime. So 4 can't be prime. 5 is prime, divisible only by itself and 1. 6 is not prime. 7 is prime. Now before you think, okay, this isn't bad, they're all going to be odd numbers, ask yourself, is 9 a prime number? And you need to say no, because 9 is not only divisible by 1 and 9, it's also divisible by 3. And since we've reached the end of the line, that means it'll be the numbers 2, 3, 5, 7. Now, if I'm writing the intersection of these two, that will be my answer, 2, 3, 5, 7. So in other words, the prime numbers that are less than 10 would have been a subset of that first set of numbers, 1 through 9. Now, if you look at 6, 7, and 8, we're all three of these being asked to find a complement or a prime. In other words, they're going to tell us what is our universal set that we'll start with. In this case on 6, it's A, E, I, O, U. And we're going to give the complement of A, or A prime. And the values in A are the letters A and E. So that means I want everything that's not in A, but is in the universal set. So I'm going to take off A and E, and that means I'll have I, O, U. And that would be my solution. Now in 7, we've got a set of numbers. We're told A is 1, 3, 5, 7, 9, or in other words, the odd numbers that are less than 10. We want to find the complement of A, all of the numbers that are in the first set that are not in A. Well, that's going to be my even numbers. So 2, 4, 6, 8, and 10. All right, here's another prime number question. We need the prime numbers that are less than 20, and then we have set A that's given. We want the complement of A. Now I'm going to do what I did a minute ago for practice sake. But first, I'm going to ask you to take a moment and find all the numbers you think are prime that are smaller than 20. So you may want to pause the recording for a minute. You should have come up with 2, 3, 5, 7, 11, 13, 17, and 19. Those are going to be the prime numbers that are smaller than 20. Now, if A is 3, 7, 11, and 17, then the complement of A will be everything except 3, 7, 11, and 17. That leaves 2, 5, 13, and 19. Let's go to the next slide. Okay, we have one more where we're supposed to find the complement of A. So U is going to be the positive integers less than 15. In other words, that will be the numbers 1 through 14. And A is positive integers that are divisible by 3, and the numbers are less than 15. Okay, now I want you to write out what you think would be the numbers that would be in A. You can pause the recording, and then let's see if you get the correct set when you're looking for A complement or A prime. You should have 1, 2, 4, 5, 7, 8, 10, 11, 13, and 14. That would be every number that's less than 15 and is not divisible by 3. Okay, let's talk about the difference between the subsets and being an element of a set. When we list all the subsets, it means every possible way that we could show what would be a part of this original set. Now, if you look at 10, set P only consists of lowercase p. So you might think, well, as a subset, that's pretty easy. It's just P. With one important thing to remember, there is something that will always be a subset of every set, and it's the empty set. That is also a subset. So if you just give 2 braces with nothing inside, that shows that's the empty set, because I could choose not to have anything in that set in addition to having P. Those would be the 2 subset possibilities. Now that's a different question from, is the empty set an element of P? Because if it's an element, that means that it is one of the values that's listed. And the empty set is not a listed value. That simply means we don't have anything in a set. So if you're answering the question, list all the subsets, be sure to include the empty set, because it will always be a subset of any set. But if you're listing the elements, you don't include the empty set. So is the empty set an element of P? The answer is no. So make sure you know the difference on those. Now on T, the only thing different is instead of only one value in our set, we now have 2. So if we're listing all the subsets, this is one way I would do it. First, you can list every value that's in there separately. So I'm going to have a set with A and a set with B. Now I can have a set that has both A and B in it. So AB. The only thing I have not included would be the empty set. So there should be 4 subsets for set T. Notice we separate each of these subsets with commas. Now in 12 we have 3 different elements inside set M, and we're supposed to give the subsets. So you might take a second, see if you can figure out how to do that, pause it, and then come back and see if you've gotten it correct. You would have set A, set B, set C. That would give us the individual elements in a set. Now I'm going to put 2 elements in a set. So I could have AB. I could also have AC. If I move to the next element, which is B, now notice I've already included A and B together right here. So I don't want to put BA. That would be the same set because the order I write it in doesn't matter. But I don't have BC. Now that I've covered all the, if I try to put C in, I've already got C with both A and B. So there's no new sets to list with C first. That means I need to put all 3 in a set, A, B, C, and then don't forget the empty set. You should have 8 different subsets listed on this problem. Last slide. Okay, we are given a diagram and we're going to find how many elements are in the indicated sets. Now if you look at 13, here's what you see. You have this big rectangle that has a U up in the corner. So everything inside the rectangle is your universal set. That's what you're looking at, okay? And inside that rectangle, you see 2 circles. One is circle A, one is circle B, and then you see an area where they overlap. We are given values inside each of those regions, and we are given this value at the bottom of 150. That means there are also 150 elements inside the rectangle that are not inside those circles. So if we answer on A, what would be the number of elements in the universal set in set U? All I have to do is add up everything that I see. Set A has 80, set B has 50, the intersection of those sets is 20, plus everything that's not in those circles is 150. If I add that all together, I get 300. Now on B, I'm trying to find U prime. That means everything that's not in set U. Well, if you look at the diagram, there's not anything that's shown outside that rectangle. The answer to that question is 0. Everything is inside set U. If you look at C, we want to find A intersected with B. So the intersection of A and B means I just want the values where these 2 circles overlap. And that's going to be 20 because that is right here. All right, on D, I want A union B. Remember with union, I want everything that's in A or that's in B. So if I add up all of these values that I see inside either of these 2 circles, I get 80 plus 20 plus 50, which is 150. And that would be the answer. Now on E, we want A union B complement, or A union B prime. So if I were to look at everything that is in either set A or set B, the complement means I want everything except that. So if I look at everything that's outside the circles, it's going to be 150. And it's this 150 right here. Okay, on F, we have A intersected with B prime. Now think about what this means. I want everything that's in set A and not in B. So everything that's in set A, but it's not in set B. So that means I've got to look inside here, inside this circle, but I do not want to use the part where the circles overlap, because not only is that part in A, but it's also in B. So if I want it in A, but not in B, that's going to be 80, because that's the only part that's in A but not in B. On G, I want A prime intersected with B. So that means I want everything that is not in A but is in B. So if it's not A but it's in B, that's got to be this part right here, 50. And then the last one we're asked to find is the complement of A intersected with the complement of B. So this means I want what's not in A and not in B. Well, if I look at this Venn diagram, if it's not in A and it's not in B, it means it can't be inside either of those circles. And what's not inside either of those circles is this 150 right here. Okay, there is another one of these Venn diagrams just below here that I want you to try to answer these same questions yourself. So there's going to be an A, B, C, D, E, F, G, H, the same ones that are listed at the top of the page. The only thing that's different here will be the numbers. All I'm going to do is write these values on here after you've paused. Then I want you to turn it back on, check to see if you got the right values.